Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to describe a shortcut for calculating the sum of an arithmetic sequence. So just a little reminder, an arithmetic sequence are sequences that look like this. I put a quick numerical example down. Sequences that look like 5, 7, 9, 11. Notice that to get from here to here, I got there by adding 2. Then here to here, adding 2. Here to here, adding 2. So arithmetic sequences have some difference here that I call D. In general, a formula for the nth term of the sequence looks something like this. It's equal to an A1, where the A1 represents the first term, in this case 5, plus some difference times the quantity n minus 1. And again, this is starting at n equals 1. Now, if we kind of write this out a bit more abstractly, just leaving these values in, that means that this is going to equal some A1. Right? And comparing that to my numerical example, that would be A1 would be 5, plus A1 plus some difference. And again, in this example, that would be 5 plus 2, which is 7, plus A1 plus twice the difference. In this example, that'd be the ninth term. Notice that's equal to 5 plus 2 times 2, plus A1 plus 3 times the difference, and so forth. So these things that I've underlined in green here are the values of the sequence, and this just goes on, or could conceivably go on and on forever. All right, now, if I were to write out a formula then for the sum of that sequence, all right, that would be A1 plus this green one, A1 plus D, plus this green one, A1 plus 2D, and so forth. And this would go on and on and on until we get to the last one here, which I'm just going to call A sub n. Now, you can also write this sum out backwards. This is just what I call a little math trick here. If we write the sum backwards, that's like starting here and going to the right, the very last term is A sub n, plus the next to the last one is A sub n minus D, plus the next to the last one from that would be A sub n minus 2D, and so forth, and this would go on and on and on until we got to A1. Now what we're going to do is we're going to play a little math trick on this. I'm going to get rid of this guy. Whoops, not what I wanted to do. There we go. Wanted to get rid of that. All right, and the math trick we're going to do is we're going to take these two equations and add them together, which means we would have 2 s sub n on the left, and again, the s sub n stands for the sum. Now, if we kind of look at this, there's kind of a grouping here. Look at if I group these together. A sub A1 plus A to the n, plus, here's another A1 times A to the n. Here's another A1 times A to the n. And there's going to be another one here, 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 here. We're going to get all the way to n. There's going to be n of those. So that sum is equal to A1 plus A to the n times n. And again, because here's one of those sums, here's a second one, here's a third one, and this is going to go all the way until we have n of those. So A1 plus A to the n times n is the sum of all those terms. Now, another thing I'd like to point out here, there's more stuff going on. I'm going to do these in blue. Look at right here. We have a D minus D. Those add to 0. 2D minus 2D. Those add to 0. 3D minus 3D. Those add to 0. Those terms are just gone. They're just completely gone. And we've taken everything into account now. So if we take the top equation and add it to the second equation, we get this very, very, very simple looking equation here, and you can solve for the sum very easily just by dividing by 2. N over 2 times A1 plus A to the n. So what that means is if I have, say, a 50-term sequence, I can find the sum of the 50 terms by putting a 50 here, the first term and the last term, provided that I would need a formula for calculating the last term. In this equation here, we're going to use quite a bit in upcoming days here for calculating the sum of arithmetic sequences. Hope that this video helps demonstrate the equation. Have a great day.